Welcome to my channel. Today we are talking about what is state management in Flutter 10-minute video. You are building a Flutter app, and everything starts simple. You have a single screen, a counter widget, and you call setState. It works perfectly. The framework rebuilds the widget, the screen updates, and you feel like a genius. But then your app grows. Suddenly, your shopping cart screen needs to know what was added on the product detail screen, which is nested 5 levels deep inside a totally different navigation tab. If you try to use standard stateful widgets here, you have to pass callbacks down through dozens of constructors. This is called prop drilling, and it turns your elegant codebase into a spaghetti nightmare within days. To understand why this happens, we have to look at Flutter's core architectural philosophy. UI is a function of state. In old imperative frameworks like Android's XML layouts or iOS's storyboards, you grabbed a direct reference to a text view and manually mutated it with something like setText. In Flutter, you don't mutate UI elements. Instead, you change the underlying data, the state, and Flutter rebuilds the widget tree from scratch to match that state. This is incredibly elegant, but it means that whoever controls the state controls the entire screen. When state needs to be shared across multiple screens, the native setState mechanism breaks down because it is strictly local to a single widget. Before we look at the solutions, we have to draw a clear line between the two main types of state in Flutter. First, we have ephemeral state, which is local state that lives inside a single widget. Think of a page view's current index, an animation's current progress, or whether a drop-down menu is currently expanded. You don't need fancy state management for this. setState is the correct tool. The real headache is app state. This is global state shared across multiple parts of your app, like user authentication status, database caches, or shopping cart items. This is what we actually mean when we talk about Flutter state management. Every single high-level state management package in the Flutter ecosystem, from provider to riverpod to block, relies on a single built-in low-level widget, the inherited widget. Instead of passing data down through constructors, an inherited widget sits at the top of your widget tree. Any widget beneath it can query it directly using build context. When the data inside the inherited widget changes, it automatically notifies all descendant widgets that registered a dependency on it, triggering a targeted rebuild of only those specific widgets. It is incredibly efficient, but writing raw inherited widgets requires a massive amount of boilerplate code. Because raw inherited widgets are so verbose, the community created Provider. Think of Provider as a wrapper that makes inherited widget easy and clean to use. It works hand in hand with Change Notifier. You create a model class that extends Change Notifier, define your state and modification methods, and call notify listeners whenever something changes. Down in your widget tree, you wrap your target widget in a consumer or use context.watch. This tells Flutter to rebuild only that specific widget whenever the Change Notifier updates, preventing unnecessary rebuilds of the entire screen. While Provider is great, it has one major flaw. It is completely dependent on the Flutter widget tree. If you try to read a provider using a build context that doesn't have that provider as an ancestor, you get a runtime error. To solve this, the creator of Provider built riverpod. Riverpod is a complete rewrite that stores providers as global constants outside of the widget tree entirely. It catches errors at compile time rather than runtime, eliminates the need for build context to read state, and allows you to easily combine multiple providers. It represents a massive leap forward in safety and testability for large-scale production apps. If you are working in a large team or a highly complex enterprise app, you will often see the block pattern, which stands for Business Logic Component. Block enforces a strict unidirectional data flow using Dart streams. The UI never calls methods directly on the block. Instead, the UI dispatches events. The block processes these events asynchronously, runs your business logic, and emits new states back to the UI. This absolute separation of concerns means your UI is completely dumb, making your code incredibly easy to unit test. However, this structure comes at the cost of significant boilerplate code. Not every app needs the structural weight of Block or even Riverpod. In recent years, reactive state management solutions like Signals and GetX have gained massive popularity. Signals, inspired by frameworks like Solid.js, uses fine-grained reactivity. You define a signal with a value, and whenever that value changes, any widget wrapping that signal automatically updates without a manual listener setup. GetX offers a similar zero boilerplate approach with its observable variables, though it also bundles route and dependency management, which some developers find overly intrusive. These tools are perfect for fast-paced prototyping. No matter which state management solution you choose, the golden rule remains the same. Minimize your rebuild scope. When a state change occurs, Flutter goes through its three trees: the widget tree, the element tree, and the render object tree. If you call setState at the root of a massive page, Flutter has to recreate the entire widget tree for that page, causing performance drops and frame skips on lower-end devices. Good state management isolates the rebuild to the smallest possible leaf widget, ensuring your app runs at a locked 60 or 120 frames per second. So, how do you choose? If you are a beginner building small to medium apps, start with simple, stateful widgets and learn setState first, then adopt Provider to understand the concept of inherited data. If you are building a modern production app and want compile time safety with clean architecture, Riverpod is currently the industry favorite. If you are entering a corporate environment with strict testing pipelines and massive teams, master the block pattern. There is no single correct answer, only the right tool for your specific engineering constraints. Thank you for watching this video. Please subscribe and follow.